scenario, I will be showing you how you can find the location of a cannon and where the cannonball launched from that cannon will land. Previously, I made a video on how you can find these things, assuming that there are only x and y coordinates. But in real life, there are 3 coordinates, x, y, and z. I will also be showing you how you can graph 3D objects using Python. Previously, we had a scenario where our enemy's cannon fires a cannonball. We want to locate the enemy's cannon and where the cannonball will land. Over here we have our radar. These are the radar coordinates. The radar will give us the coordinates P1, P2, and P3 relative to the radar coordinates. To find the coordinate for our enemy's cannon and where it will land, we create this imaginary coordinate so that the 3 points all line up with one of the axes. Let me show you. Here we have the radar coordinates. This will be our imaginary coordinate where we want these 3 to line up. This way, this will be like a two-dimensional coordinates, like this. First, we want to convert these 3 coordinates into, we want to find these coordinates relative to this coordinate here. So these coordinates currently are still in the radar coordinates. We want to transform them into the coordinates relative to this, our imaginary one. After that, we can use our previous formula, ax squared plus bx plus c, and we get these 2 points. After we find the 2 points, which will be in our imaginary coordinates, we want to convert them back into our radar coordinates. And after that, we convert our radar coordinates into GPS coordinates. So let's have a look. Here, this will be our radar coordinates. This will be our imaginary coordinate. Let's go further in. For each of our coordinates, we have our unit vectors. So for this coordinate, we have unit vectors here and our unit vectors. We want to find the relationships between the unit vectors of the 2 coordinates. So here we have the unit vector of this coordinate. Here we have the relationships. And to manage this more easily, we can put inside matrices. So we have these, we put inside this matrix. It equals to over here. And as you can see here, we can take these numbers and say this equals to this times this. Now, we can call this A. So A will be the relationship between the unit vectors of this coordinate and this coordinate. The vector OP is what we want to find right now. So currently we have P. And currently we have the coordinates P, which are, relative to our imaginary coordinates. We want to find P relative to our original coordinates. So here we have our formula. Let's see. Now we get here xp, yp, zp is the xyz coordinate for this point relative to this coordinate equals, here we get our answer. And what if we have this point relative to our large coordinates and we want to find this point relative to the small coordinates. We simply do the inverse. Here we get this. Now let's have a look at our Python program. Let's see. Let me first get rid of some of these. Here I graph this circle. To do that, we have these modules, as you can see on top. Here I can define my function. The general function for a circle is plus minus, let's see, radius square minus x square square root. And in my case, I have the x into the y. Now I graph it, and this is what I get. We can also do more 3D-like shapes. But before that, let's just change this function a bit. Let me first remove this. If you want to visualize a function in 3D form, you can simply put it here. Here I want to return square root of it. We get this line. Now let's have a look at more 3D-like coordinates. Here we get this cone, and you can have a look at this. You can have a look at the code here. Here I basically have this function. This is the function for a circle. And then for each iteration in this for loop, I reduce the radius little by little, and the z-coordinate. Let's see. The z-coordinate. Wait a minute. The radius gets larger little by little, and the z-coordinate goes up little by little. So we form this cone. This is the end of this tutorial. In my later tutorials, I will be showing you how we can find the relationship between the vectors of each coordinate. Please subscribe to my channel. It's called NetsEDU. Thank you for watching. Please hit the thumbs up button if you enjoyed this video. Today is February 1st, 2020. Thank you for watching and have a nice day.